The circulatory system is a vital system, and its constant movement of blood allows for gases and nutrients to be exchanged so the trillions of cells in your body can carry out their important functions. However, there's an unsung hero of the cardiovascular system that you don't always hear about, and it's called the lymphatic system. Without this system, the cardiovascular system would stop working, because it is this system of vessels that picks up fluids leaked from blood vessels and returns them to the blood. In this lesson, we'll take a closer look at this unsung hero, its parts and functions. As mentioned earlier, blood circulates through your body exchanging gases, nutrients, and wastes. We previously learned that the circulatory system is a closed system, but on closer inspection we see that it's not completely watertight. The super thin walls of the blood capillaries are a little bit leaky. The pressure of blood entering capillary beds forces some fluids out of the capillaries and into the tissue spaces. Now this may not seem significant, but over the course of a day, this adds up to about 3 liters of fluid. Considering that the average human body only has about 5 or 6 liters of blood, you can begin to understand the importance of the lymphatic system. Now, these leaked fluids, along with any blood proteins that were forced out of the bloodstream, must be returned to the blood to maintain adequate blood volume. Also, if the fluids remained in the tissue spaces, it would accumulate and lead to edema, which is an excessive accumulation of fluid in tissue spaces. This edema would show up as swelling in the legs and other areas of your body. So how does this fluid return to the bloodstream? Well, that's the job of the microscopic lymphatic capillaries. Lymphatic capillaries are the smallest lymphatic vessels and collect fluid from the surrounding tissues, and they're cast like a spiderweb among the capillary beds. Now, although they are similar to blood capillaries, lymphatic capillaries are more permeable, and therefore they're more prone to allow the passage of proteins or even larger particles such as bacteria and viruses. But this might sound like a problem, right? Because if bacteria and viruses, or even cancer cells, can enter the lymphatic system, then they should be able to travel through your body. However, we see that fluid within the lymphatic system must travel through lymph nodes, which are small bean-shaped organs that act as filters of disease-causing agents like bacteria and viruses. Lymph nodes are widely distributed throughout your body, and though they're part of the lymphatic system, they're often considered organs of your immune system because they contain immune cells. Now, the fluid picked up by the lymphatic capillaries is called lymph, which is simply defined as the fluid contained within the lymphatic system. Now, it's interesting to note that lymph has a composition similar to that of blood plasma, but because of lymph's ties to the immune system, we see that lymph contains disease-fighting white blood cells. Now, after the lymph is picked up by the lymphatic capillaries, the capillaries converge into larger lymphatic vessels. Now, these are sometimes referred to as lymphatics and are similar to blood vessels, but they do not carry blood. Of course, they carry lymph. They are defined as channels that carry lymph from the body to the bloodstream. Now, the lymphatic vessels direct lymph toward the upper chest, where they finally return to the venous blood system through one of 2 large ducts. The right lymphatic duct is a short vessel that drains lymph from the right arm and the right side of the head and chest. The right lymphatic duct empties lymph into the right subclavian vein near the shoulder, where it's only a short distance back to the heart. The thoracic duct drains lymph from all other areas of the body and empties the lymph into the left subclavian vein at the opposite shoulder. Now, it's interesting to note that the lymphatic system drains into the venous system all the way up at your shoulder region. So if you think about it, lymph must move upward against gravity. Now, we know that the lymphatic system is under low pressure, and we know this because the lymphatics are not part of the closed circulatory system, so they can't benefit from the pumping of the heart. So like veins, we see that lymphatic vessels have thin walls, and the larger ones contain one-way valves. And we see that lymph is transported by the same mechanisms that aid the return of blood through the veins. Therefore, we see that the return of lymph to the blood is aided by the milking activity of the skeletal muscles. So as muscles that surround the lymphatic vessels contract and relax, the blood is milked through the vessels toward the heart, kind of like squeezing the bottom of a tube of toothpaste. Lymph flow is further enhanced by pressure changes in the chest that naturally happen when you breathe, kind of like sucking up fluid through a straw. In addition, rhythmic, smooth muscle contractions of the larger lymphatic vessel walls help to push the lymph along. Let's review. The lymphatic system is the unsung hero of the cardiovascular system. Its job is to pick up fluids leaked from blood vessels and return them to the blood. If this fluid were not removed from the tissue spaces and returned to the blood, your blood volume would plummet within a day, and you would experience edema or swelling due to the excessive accumulation of fluid in the tissue spaces. The microscopic lymphatic capillaries are the smallest lymphatic vessels and collect fluid from the surrounding tissues. Once picked up, the fluid contained within the lymphatic system is called lymph, and it continues its journey through lymphatic vessels, which are simply the channels that carry lymph from the body to the bloodstream. Along the way, lymph encounters lymph nodes, which are small bean-shaped organs that act as filters of disease-causing agents like bacteria and viruses. Because the lymphatics are under low pressure, they need a little help to propel lymph. Therefore, we see that the larger lymphatic vessels contain one-way valves. Also, we see that the return of lymph to the blood is aided by the milking activity of the skeletal muscles and pressure changes in the chest that naturally happen when you breathe. In addition, rhythmic smooth muscle contractions of the larger lymphatic vessel walls help to push the lymph along. Lymph ends its journey near your shoulders, where it empties into two ducts. The right lymphatic duct drains lymph from the right arm and the right side of the head and chest. The thoracic duct is found near your left shoulder and drains lymph from all other areas of your body.